In the previous video, we learned how we can limit the scaling of our charts. In this video, we will go one step further by dynamically adjusting the scaling by setting both a limit and analyzing our data before we represent it. We will enhance the code from the previous video by reading in the data we are plotting dynamically, averaging it, and then adjusting our chart. While we would typically read in the data from an external source, in this video, we create the data we are plotting using Python lists. Here, we are creating our own data in our Python module by assigning lists with data to the x values and y values variables. In many graphs, the beginning of the x and y coordinate system starts at 0, 0. This is usually a good idea, so let's adjust our chart coordinate code accordingly. Let's modify the code to set limits on both the x and y dimensions. Now that we have set the same limits for x and y, our chart might look more balanced. Let's run it and see. We get something like this. Okay, maybe starting at 0, 0 was not such a great idea after all. What we really want to do is to adjust our chart dynamically according to the range of the data, while at the same time restricting values that are too high or too low. We could do this by parsing all the data to be represented in the chart while at the same time setting some explicit limits. Modify the code as shown here. Let's see if the output changes. Running the code results in a chart like this. We adjusted both its x and y dimensions dynamically. Note how the y dimension now starts at 5.5 instead of 5.0, as it did before. The chart also no longer starts at 0, 0, giving us more valuable information about our data. What did we do? We are creating a list of lists for the y dimension data, and then using the list comprehension wrapped into a call to Python's min and max functions. If list comprehensions seem to be a little bit advanced, what they basically are is a very compressed loop. They are also designed to be faster than a regular programming loop. In this file, we created 3 lists that hold the y-dimensional data to be plotted. We then created another list that holds those 3 lists, and this in turn created a list of lists. We are interested in getting both minimum value of all the y-dimensional data as well as the maximum value contained within these 3 lists. We could do this via a Python list comprehension. After running the list comprehension, min y is 5.5. The one line of code above is the list comprehension that runs through all the values of all the data contained within the 3 lists and finds the minimum value using the Python min keyword. In the very same pattern, we find the maximum value contained in the data we wish to plot. This time, we also set a limit within our list comprehension that ignores all values that are above the limit we specified. After running this code with our chosen restriction, max y has the value of 8, not 50. We applied a restriction for the max value according to a predefined condition, choosing 20 as the maximum value to be displayed in the chart. For the x dimension, we simply called min and max in the matplotlib method to scale the limits of the chart dynamically. Awesome! That's about it in this video. We used core Python to control the scaling of the charts dynamically. We're at the end of section 5. Here, we learned how to create charts using matplotlib and then downloading various modules for matplotlib. After that, we created our first chart. We placed labels and then a legend on charts. Finally, we learned how to scale charts and then adjusted it dynamically. In the next section, we'll explore threads and networking.